Good morning, everyone. This is lecture number 2, and we are dealing with motion in one dimension. Well, if you recollect in the previous lecture, what have we covered? Can anyone tell me? What have we done in the previous lecture?
Types of motions.
Yes,
Period.
in the previous lecture, we were trying to understand what motion is, not motion is, what are the types of motion, what are the branches of mechanics, what we have to study, and what all tools we require to study. We need an observer, we need a reference frame, and we need a timing device. Do we remember this? Everyone remembers it? Well then, now we start today's lecture, and the first thing that we are going to study in today's lecture is known as position vector. Have you heard this term, position vector?
Yes, sir.
Well done. Position vector. So that is the first heading that you shall write. Position vector. What do you mean by a position vector? Anyone? If you know it, then you know it. What do you mean by a position vector? Anyone?
A vector which shows the direction.
It is a vector which shows the vector by magnitude of unit vector, sir.
A vector by the magnitude of unit vector. I did not get what you wanted to say. Can someone try again?
Sir means vector consists of 3 dimensions, sir. X, Y, Z.
What I'm asking is definition or meaning of position vector.
Sir,
Are you sure you are giving me the answer for the same thing? Yes,
sir,
beta.
a vector which shows the directions.
A vector which shows the direction. Okay. Position. Why can't you just look at the term? Remember, most of the terms in physics are going to tell you by their name only what they are going to do. Try again. What is a position vector going to do? Position vector is going to tell us what?
Position of the vector.
Position of a point. That's it. But again, if you want to understand or if you want to give the position of a point, the first thing that we need is a what? What is the first thing that we need? Describe the position of any object. We need a reference frame. Do we remember this word, reference frame? Do we remember this word, your reference frame? Yes or no?
Sir.
X, Y, and Z axis. In that reference frame, we have an origin. So once we specify our reference frame and once we specify where our origin is, right now you can see the reference frame as well as you can see the origin and you can see the X, Y axis. I have not drawn the Z axis because that we just does not make sense. I cannot draw it. It's a two-dimensional board. I can only draw 2 dimensions here. Now, I have a reference frame. I have an origin. Now, tell me, what do you mean by position vector? It's a vector that is going to show us or give us the position of what? It is going to give us the position of this point.
Reference.
It is going to give us, and this is not looking good, so I'll just draw it with my own hands. It is going to give us the position of point P with respect to O. This OP vector, this OP vector is doing what? This is giving us the position of, this is giving us the position of point P with respect to O, and this OP vector is known as what? This is known as
Resultant.
the position vector PV of P with respect to O. We are talking about position vector. Why are you getting all those fancy terms into the picture? Resultant vector, this, that. Position vector. OP is the position vector of P with respect to O. And what is this vector doing? This vector is giving us the position of point P with respect to O. Do we understand this? Is it difficult for you to understand this? You look at the name and you understand the meaning behind the name. Position vector is a vector which gives us the position of any point with respect to the origin. Do we understand this? Everyone in the class, we understand this? Now, you can write it as OP vector. And remember, OP vector is the position vector of P with respect to O. If you look closely, we have said P first and O later. P first, O later. But when I have written O first and P later. Now, this sometimes creates a doubt in my head. So there is one more way of writing this OP vector. OP vector is the position vector of P with respect to O. It is a vector drawn from O to P. But instead of writing it like this, I can write it like this. R vector PO. And this is how I will normally write it. R vector PO. Now it looks like a very difficult representation of a very simple thing. You could have said, sir, simply OP vector. Why you are writing it in a fancy way? I'm not writing it in a fancy way. I'm trying to make you understand. Sometimes what happens is what you speak is what you understand. If you say something wrongly or not in the correct way, you are definitely not understood this. So just to make a point, I am going to write it as R vector PO. And when I write it like this, you know what I mean. This R, basically, if I talk, this R means position. Now you will understand why I've written like this. This arrow ka sign, we all know this arrow ka sign means vector. Yes or no? So if I look at this entire term R vector simply means position vector. Yes or no? R vector means position vector and R vector PO. Now, if I say it in the language, I will say it like this. Position vector, which is represented by R and vector of P with respect to O. That is one other way of writing this position vector, and this is the way that I prefer, because in this way what I have done is I have written it in the same way in which I am going to talk about it. Do we understand this? R vector PO, R standing for position, arrow standing for vector. R vector PO means position vector of P with respect to O. OP vector also means the same thing, but in OP vector I am saying it as OP and then I am calling it position vector. That in my books looks a bit confusing. Do we understand this position vector, everyone? Everyone has noted this down? Okay. That takes us to the next heading. And the next heading is the most basic of all headings. The next heading is rest. To understand motion, we have to understand what do you mean by rest. If you understand rest, then you understand what is motion. So again, I give you the liberty of telling me, the choice of telling me, what do you mean by rest? When do we say an object is at rest? Yes. Remember, simple things is what you have to understand. To understand these simple terms, entire physics becomes simple. If you don't understand them, and by understanding, what I mean is you'll have to get the meaning of that term. You should be able to describe rest to anyone that you meet. If you can do that, that means you have understood rest. Otherwise, everyone understands rest. But we have to understand rest in the correct way. Yes. What do you mean
The
by
Sir, the position of the body which does not change with respect to time, sir.
okay? You look at me, am I at rest?
Sir, you are at rest, sir.
No. So your definition fails. Because you have missed the most important point of this definition. Your definition is only half true. And remember, half true is sometimes very dangerous. Either you know it or you don't know it. If you know it half, it's very dangerous. Can anyone try again? He has missed a very, in fact, the most important aspect of the entire thing. Yes,
If a object doesn't change its position with respect to time.
same thing. You also missed. So, am I at rest? According to your definition, yes. I am not. So the definition again fails. You missed the most important aspect of this. You missed the most important point, and that is it. Once you miss the most important point, you only have half knowledge, and that half knowledge is going to trouble you because when a question comes based on the other half, we are all stumped. Anyone else?
Rest is nothing but I have no motion.
No, that is not correct. Again, half truth. You are saying the same thing in different ways, my dear friend. You hold the ear like this or you hold the ear like this, you are still holding the ear, but you are holding it wrongly. You have missed the most important point of holding the ear. And everyone has missed it. I have got three definition and they are all missing the
Net
same
moment is
thing.
zero.
Yes?
Net moment is zero.
Net?
Moment.
I don't know what do you mean by that. I'm sorry. Probably beyond my comprehension to understand such typical terms. Remember, when you're trying to define something, you can only define it in terms of things that you know. You cannot define it in terms of something that is going to come. So rest cannot be defined in terms of force. Rest cannot be defined in terms of distance because even the definition of distance has not come. So I have to define rest only using those things that I know, that I have told you. You missed the most important aspect and you have to realize that you have missed it. It's okay. So now I'll give you a hint of what you have missed. The length of this pen is 5. That is what you have missed. Do you understand what I missed here? The length of this pen is 5. Do you understand what I'm saying? The length of this pen is 5. Do you understand? Do you understand the length of this pen now? Yes or no? I've told you the length of this pen is 5. Do you understand it now? How much is the length of the pen? Yes or no? Either say yes or no.
No, sir.
No, you don't understand it. That is the same thing that you are doing right now. You're defining rest in terms of something that I don't understand. Because I missed the most important aspect of this length. What I missed? What have I missed? When I say the length of this pen is 5, I missed the most important aspect. And what is the most important aspect that I missed?
Unit.
Yeah?
Unit.
Unit. So now do you understand what is the most important aspect that you have missed?
Unit, sir.
I don't call it unit. We call it what?
Units.
We don't call it unit now. Unit is for length and measurement. That means no one went through the entire class of the last day and everything goes down the drain. Shameful. If this is the way you are going to study, I can give you in writing that we are not going to go anywhere. We have missed the most important aspects. And what is the most important aspect? Yes, what is the most important aspect that you have missed?
Reference frame, sir.
Reference frame you have missed, my dear friend. I am not at rest. You see me at rest from where you are sitting. A person outside Earth in a spacecraft. Does he sees me at rest? No, sir. He sees you moving. That means you have missed the most important aspect. Unit. What you have compared it with. When you are saying rest, with reference to what you are saying it at rest. And that is the most important aspect, the reference frame. So, how do you define rest in the complete way? A body is said to be at rest when a body is said to be at rest with respect to a given RF. What do you mean by RF? What do you mean by RF?
Reference frame.
If its position does not change with time with respect to the given reference frame. Remember, rest or motion, they both are relative terms, and we will write it once we write the definition of motion. Rest and motion both are relative terms. The most important aspect is they are relative terms. It depends on the reference frame from where you are watching this motion. The same motion can look different to different people. I gave you the example of the bus. Two people sitting in the bus moving, and third person outside. To the person who is sitting on the bus, when the other person looks, he's at rest. But to the person who's on road, that person is moving. Rest and motion are relative terms. Do we understand this? Can I have some reason that we understand this? And the most important feature of this definition is this one, because this is the aspect that every one of us misses, and this is the most important thing that you should not miss. Now, having told you what is rest, I hope you can tell me when do we say a body is in motion. Yes. Now tell me the definition of motion. What will be the definition of motion?
A body is said to be at motion with respect to given reference frame. Its position change with respect to time, sir, with given reference frame.
Yes. The only difference now you have to make in the definition of motion, everything remains same. The definition would be like this. A body is said to be, instead of writing it at rest, you will write a body is said to be in motion with respect to a given reference frame. If its position, instead of does not, you will just write change. If its position changes with time with respect to the given reference frame. Do we understand this? I'll give you a minute. I am not going to write the definition again. You'll have to write it after making the corrections that I have shown in green. Instead of at rest, it will be in motion, and the word does not will not come. A body is said to be in motion with respect to a given reference frame if its position changes with time with respect to the given reference frame. Do we understand this, everyone? You will have 1 minute to note it down. The definition of rest and motion. Have you noted it down? Everybody noted down the definition of rest and motion. Then you will write the most important aspect. Rest and motion are what type of terms? Rest and motion are relative terms. Rest and motion are relative term. What do you mean by this letter relative? Everything in this universe is relative. Nothing is absolute. Sir Albert Einstein said this. What do you mean by this relative term here in this definition? Rest and
Which are
motion
connected.
depend on not
Depend on each other.
depend on
Each other.
they depend on reference frame, my dear friends. It is so difficult to understand. Rest and motion are relative terms. They depend on through which reference frame or on which reference frame are you watching them. So they depend on reference frame. We call them relative terms. Terms that depend on reference frame, on relation with what you are comparing them with. If you are looking at the motion from a moving bus, motion would look different. If you are looking at the motion from ground, the motion would be different. Rest and motion are relative terms. Do we understand now what do you mean by the term relative? Okay. Then comes the next heading, the next definition. What will be the next definition? Tell me. We have done rest, we have done motion. What will be the next definition, my dear friends? Yes? No idea? The next definition is the definition of distance. Distance traveled. And I again ask, what do you mean by distance? Yes, beta. Remember, you'll have to define the terms correctly. Then only you are going to understand them. If you cannot define something, that means you have not understood it. What do you mean by distance? You would have studied this in 9th standard. Or in 11th standard, you should be able to say some definition of distance. Yes? It may be right, it may be wrong. That is not important. Right and wrong depends on your reference frame from where you are looking at it. Right and wrong does not matter. What do you mean by distance traveled or distance?
A body travel
The body travels. What? What do you mean by distance? Yes? Try.
the body travel total distance in a respective time.
So distance means the body travels distance. That is known as distance. Is
No, sir.
does it look
the-
like a correct definition?
The body travel with total distance with respective time.
The body travel total distance with respect to time is known as distance. Does that look like a correct definition? What is velocity? The body moves with velocity. That is known as velocity. Will that be a correct definition?
Actual path covered by a body.
Actual path covered by a body. Okay, now you are talking. Actual path covered by a body. Anything else you want to add there? Again, see, something that looks very simple, you must have used distance 1 million times in your life. but you still don't know what distance means, and you still know that you understand it. That's the beauty of your human brain. You may not be able to explain things, but that does not mean that you don't understand them. But that means that someone will catch you because of your misunderstanding of the term, and that is how magician works. They are called as
Respect to time.
illusionists because they just hit the weak part, and that's it. Yes. Okay. Tell me, what is the SI unit of distance? You must be knowing this. Tell me the
Yes.
SI
Meters, sir.
Meters.
meters. What type of quantity is distance?
Length L. Scalar.
Length L scalar. Now you are talking length L scalar. And then you said actual path. The actual path traveled by a body is known as distance. Do you get any sense of length from there? That it has got something to do with length? And you have not put it in the actual definition. And that is the problem. Now can you frame a new definition of distance? The sense of distance should
Body
come there.
traveling in a certain speed with respect to time.
Speed. Have I defined speed up till now? You cannot define something with using something that is going to come in the future. So I cannot say that I am the grandfather of, let me say, Monu. I am the grandfather of Monu because Monu has not come in the universe. So I cannot be the grandfather of Monu right now. If I have to define myself, I have to use something which is already present, not something which is in the future. Speed is in the future. Don't know it. Can't define distance by speed. Yes or no? Chicken or the egg? We don't know what comes first. But we definitely know distance and speed, what comes first. What comes first? Distance, my dear friend. So I cannot define distance by speed. Okay, let me help you out. See, sometimes what happens is we understand, we know that we know things, but when someone asks its definition, we are caught. The body is at point A, then the body goes to point B. Could have traveled in infinite number of ways. I'm just showing you one way. This is the way it has traveled. That way it has traveled is known as the path, or you can call it actual path, just to bring in the term actual, because the path can be different. It can have 5 paths. Of these 5 paths, he has used 1 path. So this is the actual path. And now what you told me was distance is the actual path traveled by the body. That is the actual path. Tell me what is the distance. You can't say the distance unless and until you specify what of the actual path are you talking about. And here we are talking about the length of the actual path. L. Length of the actual path. And that is how you define distance. Now can you define distance? Distance traveled by a body is the
Actual path covered by the body.
is the
Actual path covered by the body.
length of the actual path covered by the body in a given time interval. The most important thing here is length. As soon as you say length, you understand, okay, you have to measure something. When you say actual path, there is no measurement involved. Actual path traveled by a body. What of actual path? The design of that actual path. Or the topography of that actual path. How many holes were there in the road? That is distance. No, my dear friend. To specify what are we talking about? Actual path ka what? The length of the actual path. And that is why I will always define or denote distance by the letter L. So that whenever you talk about distance, this letter L comes into your mind. And what does this L stand for? This L stands for
Length of the
length of the path or length of the actual path. So whenever you're talking about distance, you are talking about length of something. And what is that something? The path followed by the body. Do we understand this? Okay, let us now highlight the important points that you must remember. What type of quantities? What type of quantity is distance?
scalar, sir.
It is a scalar quantity. Point number one. What is the SI unit?
Meter, sir.
Meter. Third point. Distance is length. Can length of a body be negative? This length is
No,
5
sir.
meters. This length is minus 5 meters. Does that happen that way? No, no. Therefore, distance traveled by a body is always,
Positive.
yes, it comes from the phenomena of length. Length cannot be negative. Length is always positive. Distance is always positive. Distance traveled by a body is never negative. Do you understand this? So once you understand the definition, everything follows. It is the length of the actual path. Therefore, it depends on the path. If you go in one path, the distance would be different. If you go in some other path, distance would be different. Yes or no?
Sir.
Please note this down. It depends on the path. Distance is never negative, it is always positive. It depends on path. Now, it is a scalar, so it is basically a number. So it can be added or subtracted like numbers. We don't need anything special to add or subtract it because it is a scalar quantity, it's a number. What do I mean by this? For example, if I go from A to B, and let me say I go like this, and I travel a distance of 5 meter, then I go from B to C, and I travel a distance of 6 meters, which is the length of the path that I have followed. What is the total distance I have traveled? What is the total distance that I have traveled from A
Sir,
to?
11 meters, sir. 11 meter.
How did you find it out? You just add.
Addition of AB to BC, sir.
Yes. You can simply add A, B ka distance with the distance from B to C, which is the length of the path, and you get your answer. It can be added or subtracted just like numbers, so there is nothing special about it. Length of the path. Once you know the length of the path, everything else is sorted out. I hope everyone has noted this down. Yes or no? Shall I move on to the next definition? Tell me, what would be the next definition, dear?
Displacement, sir.
Well done. And as always, I will ask you, what do you mean by displacement? Remember, we'll have to understand the terms very correctly. If we make
The shortest distance from initial point to final point, sir. Displacement.
everyone knows this, right? The shortest distance.
Shortest distance covered in one direction.
Shortest distance covered in one direction. It cannot be in the other direction, right? It cannot be in the other direction. That is clear. Someone says shortest distance, someone says shortest distance in one direction. Anyone else? Like to say it in a different way?
It is the shortest distance measured in one direction.
In one direction. So I cannot move in the other direction, right? Yes or no? If it is in one direction, I cannot move
The
in the other
shortest
direction.
path covered by a
Yes,
body
sir.
from initial position to final position.
The shortest part covered by a body from initial position to final position. Okay. What type of quantity is displacement? That is the first question that I'll ask.
Vector.
It's a vector.
quantities.
Chalo. So let us first write this important point as it is a vector quantity. Now, as soon as you understand that this is a vector and all of you understand that this is a vector, two things must come to your mind. What are those two things? What are those two things?
Magnitude with respect to direction.
Magnitude with respect to direction. No, absolutely wrong. Magnitude with respect to direction. Be very sure of what you are saying, my dear friend. Because if you say it in a wrong way, you understand it in a wrong way. If you understand it in a wrong way, well, you understand the definition in the wrong way, how will you solve any question? Magnitude with respect to direction. No. Try it again. Students are like cash vouchers, cash cards. If one time it does not work, we'll try it again. It might work. If it is the correct card, it will work. Doesn't work the second time, third time it will work. I call it redemption. You can also redeem yourself. Your cash vouchers, you can redeem. Yes, try it again. Whenever you talk about vectors, two things must come into mind. What are those two things? Vectors is already done, right?
Magnitude and direction, sir.
Magnitude and direction, not with respect to.
With
Ye-
respect.
Not with respect to. Because if you say it wrongly, that means you have not understood it properly. Magnitude and direction. Now, again, try and tell me what is displacement. Remember, it's a vector, so two things must be there. If two things are not there, we are done. No point of getting the definition if it does not have two things. Yes or no? This is O. The body is at A. It goes to B. It goes like this, jung, 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 jung. The length of this path is known as what?
Distance, sir.
Distance. Okay. Second question. What type of motion is this? Is this motion in 1D, motion in 2D, or motion in 3D?
In 1 day, sir.
The motion that I have drawn is motion in 1D. Sure?
Motion in 2 days, sir. Sorry.
Motion in 2D. It's a motion in a plane, right? Motion in 1D is only in a straight line. So this is motion in 2D. So basically, whether it's 1D motion or 2D motion or 3D motion, remember, definition remains same. We don't define definition. Okay, for 1D motion, bacho, please write this definition. For 2D motion, bacho, write this definition. For 3D motion, bacho, write this definition. No, it does not happen that way. Definition remains definition. Definitions are not bounded by the dimensions. Do we understand this? The definition remain definition. I have started with motion in 2D. That means whatever definition we are going to give is applicable for 1D or 2D. The body goes from A to B. It's a two-dimensional motion. The length of this path is the distance. What is the displacement I'm asking now? So I've shown it to you. Seeing is believing. I've shown it to you. Now, can anyone tell me what is the displacement?
Sir, the shortest distance from A to B, sir.
Shortest distance from A to B. Whosoever has told you this definition, number one, either he is a fool. Number two, if he is not a fool, he has fooled you. Number three, if he is not a fool and he has not fooled you, he has tried to make you understand something in a way which does not exist in this universe. Sometimes what we do is to make things simple, we make them understand in such a way that the entire concept goes down the drain and flushed and into the sewage. I give you an example. My son was small and I had to explain him what a tomato is. So I told him tomato. Tomato is like apple. Tomato is apple. Both are red. Both can be eaten. So what? Tomato, and they have the same shape also, right? Tomato is apple. Apple is tomato. Tomato is apple. Because that was the easiest way to make him understand. Because he knew apple. He loved apple. So he said, Papa, this is apple. This is tomato. Same like apple. Same shape. Same color. So what? Taste is different. So what? Right? Who worries about the taste? So what? One is a vegetable, other is a food, right? Who worries about it? They look similar, na. You understand apple, na, so you understand tomato. That should not be the case of we understanding something. When you say displacement is the shortest distance, my dear friend, you have killed displacement there itself. Because displacement is a vector quantity and you define it in terms of a scalar, man. You have made it scalar. You have made a fruit vegetable. And then you are saying we understand it, sir. Displacement has got nothing to do with distance. Not in this universe. Probably in some other fantasy universe where people come from. But I live in this one and this is good. In this universe, and to all my students, distance and displacement are not related to each other in any way. So if someone asks you displacement and you say shortest distance, slap yourself, take a knife, take physics ki kitab and kill it because you have killed it. Distance has got nothing, displacement has got nothing to do with distance. Not in this universe, not in any known universe that I know of. Now what is displacement again? It is a vector. That is the first thing that you must understand. And vector cannot be defined in terms of a scalar. If you are trying to define vectors in terms of a scalar, you are committing a crime. Now, what is the displacement? The simplest and the easiest way of telling you what is the displacement, the particle goes from A. So this point A is known as the initial position, yes or no? This is known as initial position. And this point B is known as what? One is initial, the other one would
Final
be?
position.
Yes, final position. Now we are talking. Remember, we have to understand things in the correct way. You cannot understand a tomato from an apple. Distance is apple. Displacement is tomato. A is the initial position, B is the final position. The displacement is, if I draw a vector from A to B, that is displacement. And it has got nothing, as you can see, with distance. Nothing, absolutely nothing. This AB vector is your displacement vector. Because it is a vector. Do we understand this, beta? Everyone? I have not used the term distance or shortest distance because that is wrong. Cannot define it in terms of shortest distance. So, if a body moves from point A to point B, sir, students, parents, everyone in the universe, AB vector is the displacement vector. It's as simple as that. So displacement, if I have to define, is a vector joining what? Vector joining what?
Initial and final position.
That now you are talking. Now you are talking like someone who's studying physics. The vector joining initial and final positions. Well done, my dear friends. See, now the essence comes out. Now it stands out. Okay, I am displacement. I am vector. And I am joining initial and the final position. That's it, my dear friends. That's my job. That's my definition. Please do not say I am shortest distance. I get angry on it. And then I'll kill you. But if I get angry and if I come in the examination, I'll kill you. Because you don't know me. I'll be the silent killer. Vector joining initial and final position, my dear friends. That is your displacement vector. Now I can write it in different ways. So let us now see how can I write it. So the first way of writing it, it's a vector joining initial and final position. This is number A. Do we understand this? Number B, you can write it as AB vector, a vector drawn from AB, A to B. That is the second way you can of writing it. Is everyone getting this? Yes or no? Okay. Now look, if you understand something, you can write it in different ways. See, I can write it like this. Remember the way I had written position vector. OP vector was written as position vector of P with respect to O. So AB vector, if I reverse it, AB vector can be written as position vector of B with respect to O. Yes or no? So basically displacement is the position vector of final position with respect to the initial position. Do we understand this? Position vector of final position with respect to initial position. Final position with respect to initial position. And now I'm going to draw it for you, my dear friends. See, this gentleman is the initial position vector, OA vector. Do we understand this? This gentleman is the final position vector, OB vector. Yes or no? I can write this vector as position vector of B with respect to O. I can write this vector as position vector of A with respect to O. Do we understand this? Now I will write it in various ways and you will see how beautiful it looks. T. Position vector of B with respect to A can be written as position vector of B with respect to O minus position vector of A with respect to O. So this basically means final position vector minus initial position vector. Is everyone following me? That is your displacement vector. Is everyone getting me? Yes or no? Well done. Now we are talking, my dear friends. Now we are talking physics. And we are not describing a tomato from an apple. Final position vector minus initial position vector. Now, this final position vector minus initial position, I can also write it like this. This will be OB vector, final position vector minus OA. See how many different ways have you understood of writing the displacement vector. Once you understand that this is a tomato and not an apple, now you understand how the tomato behaves. Now, there's one more way of writing it, and this is how I'm going to define displacement. Now, remember this terminology that I'm going to use because I'm going to use it many times. Probably I have told you about this as well. Final minus initial. Whenever we talk about final minus initial, we always talk about something which I call as change. We have changed something. Change means final minus initial. Do we understand this? Change means final minus initial. Now this change is denoted by this letter delta. This is not a triangle. This is delta, a Greek alphabet. Change is always denoted by the Greek letter delta, which looks like a triangle. So now I can write this like this. Position vector of B with respect to A is nothing but delta R vector. Delta R means change. Delta means change. R means position. Arrow means vector. So it means change in position vector, which is final position vector minus initial position vector. Do we understand how beautifully we have written this? And remember, I have not used that funny term, shortest distance, because that funny term should not be used here. Delta R vector. Do we understand the meaning of delta R vector here? Yes or no? No, yes. Please raise your hands. So with this terminology, I am going to, whenever I am going to define displacement or symbolize displacement, I will always symbolize it by this vector, delta R vector. So as soon as I write delta R vector, you will understand delta means change, R means position, arrow means vector. So delta R vector means change in position vector, and change in position vector means displacement vector. So everyone has noted this down. Yes or no? No, yes. Now, coming back to what we were talking about the important points, and in the important points, we had said that the displacement is a vector quantity. Now, we have defined it in terms of vector. To define vectors, up till now, we have already defined vectors, displacement as a vector. But if you want, you can understand it in a different way. Every vector will have two things that you must understand. Every vector has two things that you must understand. One is the magnitude and the other one is the direction. Now I'm trying to make you understand same thing in a different way. But that does not mean that this is a definition. Do we understand this? This is just for your understanding, that you understand it in a different way also, so that you don't get puzzled. So a vector will have magnitude, it will have direction. Now, first let us talk about direction, because in a vector, direction is the most important thing. What is the direction of this vector? First tell me that. What is the direction of displacement vector? The direction is from initial position to the final position. Do we understand this? I'm here. Now I'm there. From initial to final, what is my direction? That is the direction of displacement vector. Now, if I talk about the magnitude of displacement vector can be understood like this. The magnitude of displacement vector can be understood like this. It is your favorite apple. It is the shortest distance. If you want, you can understand it in this way. But remember, that is not the definition. It is the shortest distance, or I can say straight line distance. This is how you can understand it probably, if you want to. But I don't think this is a very good way of understanding the same thing. No, for me, this is a primitive way of doing it, because when you understand it in this way, this term comes in your head, which I never want to get into your head, shortest distance. So you basically try to understand displacement in terms of distance, and you cannot understand it because you will make a mistake there. Do we get this? Yes or no? Distance, displacement. Quickly, we will write some important points about this. So let us start with writing some important points. Number one, it's a vector quantity. Number two, the SI unit is meters. Number three, it does not depend on what? It does not depend on what? It does not depend on path, as it only depends on initial and final position. Do we understand this, bacha? It does not depend on path because it only depends on initial and final position. Look at this diagram that I have drawn. The particle goes from A to B. It can go in blue path. It can go in green path. It can go in this whatever color is this. I don't remember. I don't understand color. It can go in any of these paths. Blue path, green path, or maroon, or whatever color that is. The distance depends on the path because it is the length of the actual path. But displacement, whether I go from the blue path or the green path or this fancy color path, displacement is only the vector joining the initial point to the final point. Does not depend on path. Do we understand this? So that's an introduction to distance and displacement. They are not brothers. They are not even cousins. They are not related to each other in any way. They might be related in such a way that they are all human beings. So if distance is an Indian, displacement may be Japanese. But even then, they are human beings. Distance and displacement are not even related to human beings. So if one is a earthling, the other one may be a Martian, right? That would be better. If one is a tomato, the other one is an apple because they belong to different breeds. We will understand more things about them. We have seen that distance is a scalar. It is always positive. What about displacement? Positive or negative? Have you heard about? Yes.
Can be positive or negative or zero.
Again, we will try to understand what do you mean by a positive. What do you mean by a positive displacement? Have you heard positive vector anywhere? Have you heard positive vector anywhere? A vector is a positive vector, says Asik sir. Have you heard it? No, na? Have you heard about positive vectors or negative vectors? No, you might not have heard. And that is why if vectors are not positive and negative, displacement cannot be positive and negative. So another enlightening fact that is going to come in the next class. What do you mean by displacement positive and displacement negative? We'll come to that. Meanwhile, I'll give you a task to find out what do you actually mean by positive vector or positive displacement, and what do you actually mean by negative displacement. Remember, sometimes the tomato is described by an apple. If you have understood tomato by an apple, you have not done justice to both tomato and the apple because both will be sad. Oh, what a sad day for tomato, described by an apple. What a very sad day for an apple that is going to describe tomato. Let us see how an apple is described by apple itself And a tomato is described by tomatoes. They're talking about apple. Samsung must also be described by Samsung itself and not by Apple. So we will see you in the next class. Take care. Have a good day. And I'll see you. Bye bye. God bless you all.